All right, today's lesson is on exponential depreciation or exponential decay. All right, what does devaluation mean in terms of automobiles? Well, devaluation is very simple. It means the vehicle is becoming less valuable. I think that's pretty obvious as to why that is to everybody. You know, the car's in the best shape it's ever going to be when you buy it, and after that, it wears out, it breaks down, it has scratches and all that kind of stuff. It's got miles on it, it wears, and so it's worth less money. So it becomes devalued over time. So let's list three factors that might contribute to a car losing its value. Probably the number one is if it's in an accident. Okay, it can lose a lot of value real quick. I mean, you get a frame that's bent or something like that, you might be able to fix the car, but it's never going to be the same after that. Okay, number two, it's just got wear and tear. It gets some scratches on the paint, and the carpets wear out, and that sort of stuff. The engine, it gets well. That brings us to the third one: more miles or high mileage. Okay, the more miles you have in the car, the more things are working, the more they wear out. So there's all kinds of things that can contribute to it. I mean, it could be that you don't take very good care of it. Even if you take great care of a car, it's still going to lose value over time. Okay, how can we tell how fast our car is depreciating? The best way is to look at past historical data. So when you do this, it's called historical depreciation. So this table shows the value of a car over the course of a 10-year period. The graph gives a visual representation of the data, and we can assume that the car was purchased for $26,434.78. Okay, so age 1 year, car's worth $24,230. After year 2, $22,355, and so on until year 5, it's only worth $16,265. Okay, and then it continues to go to year 10. Now, if you look at the graph, here's what's happening. It's got this curve that kind of looks like this. Okay? It's not straight line depreciation like we did when we were talking about taxes. So, and the reason for that is generally a car loses value. It loses a percentage of its value every year. And so, as the car gets older, it loses value, but it loses less value. Okay, it loses a lot less value from year 10 to year 11 than it does from year 1 to year 2. That's why maybe one of the better ways to buy a car is instead of buying a new car, you can go to a place like Enterprise, okay, and they're a rental car company, and they have their fleet of cars, but people want to drive newer cars. So what they do is every 3 years they get rid of the cars, right? They sell them. Well, the worst 3 years of depreciation are the first 3. So you can go buy the car that's 3 years old. It's in pretty good shape, and it doesn't have a whole lot of miles on it usually, and you've depreciated. You got the majority of the depreciation out of it. Okay, what do you know about this data and the value of the car each year? So it's obviously going down. Okay, and it's going down at a slower rate. So it drops in value at a slower rate each year. So you can kind of see this thing is almost flattening out here. What do you notice about the shape of the graph? It's curved. Okay, now, you know, if you're going along here and the car is depreciating, and then you have an accident that's total, that changes the game. Okay? Now, it won't go to zero. Even if you total it, it won't go to zero because the car always has some value. I mean, somebody's willing to buy it and part it out or buy it and fix it or whatever. As a project car. All right, exponential decay. The previous graph we looked at when discussing historical data depicted nonlinear depreciation, as in it's not a straight line. So models like this are decaying exponentially, meaning instead of depreciating by a constant dollar amount, it's depreciating by a constant percentage. So the car might be worth 85% of its value every year. Some cars depreciate very slowly, like you get a Toyota Camry. Now, assuming you take good care of it, it might keep 92% of its value every year. Okay, whereas you get a Mitsubishi, and those things tend to depreciate a lot, it might only keep 70% of its value every year. It just depends on the car. It depends on the model. I mean, it might be like Mitsubishi, they might have one model that depreciates slowly, they might have a different model that depreciates very fast. Exponential decay can be expressed by the following equation: y equals a times b to the x power. Okay, so a is the starting value or purchase price of the car, b is the depreciating factor, x is the elapsed time, and y is the value of the car after the elapsed time x. So we're going to look again at this. This was the graph from before. When creating an equation for exponential decay, we can see we already know the starting value, A, $26,434.78. So that goes in for A right there. That leaves us having to find the value of B. To do this, we can look at the first two car values on our table. In year one, the car was worth $24,230. In year two, the car was worth $22,355. Divide them, that's your B value. Okay, so we take 22,355 and we divide that by 24,230. So we want the latest year on the top here, the numerator. So 22,355 divided by 24,230 comes out to 0.9226. That's our depreciating value. That's the number that goes in for B. So using this equation, what's the car worth after 16 years? Okay, so we've got to get our equation. Y, which is the value of the car, is $26,434.78. We're going to multiply that by 0.9226 to the, in this case, the 16th power. Now, if I wanted to make a chart, once I have these two numbers, I could put an X in here, and I could put this in my graphing calculator in my equation, and I could make a table from that. Okay, so how would I do that? I do this. I'd go y equals, I would put in 26,434.78 times 0.9226, power key, put the X in there, okay, and then hit enter. And then I can go to my table, second graph, and this started at -21 for some reason. So I'm going to go to my window, or my table set. I'm going to start it at 0. I'm going to go back to my table, and it gives me the value for each year. So I could just scroll down here to 16, and it would say 7,230 $284.40. Okay? So, now, if I was going to put this in my calculator, to calculate it, I'd go 26,434.78 times 0.9226 to the 16th power, hit enter, and guess what I get? I get this, except it came out to be 35 cents, so there was a rounding error in there somewhere. No big deal, because nobody's going to care about the cents anyway. Okay, create an equation to represent exponential decay for the following automobiles. So it's a Honda Accord, 2018. This is another vehicle that usually maintains its value pretty good. Original price 32,800 miles, or $800 with a mileage of 0. It's got air conditioning, Bluetooth, USB, heated seats, power steering, 100,000 mile warranty, and 34 miles to the gallon. Okay, here's what it's worth year 1, year 2, year 3. So, what's A going to be? That's the sale price. Okay, that's here. $32,800. Okay, what is B? Well, I'm going to take 21,520.08. I'm going to divide that by 26,568. Okay, probably you could just round it to the nearest dollar and you don't have to put in the pennies in there. So 21,520 divided by 26,568 comes out to be approximately 0.80999. So we're just going to say 81. Keeps 81% of its value every year. That's not great. So then my equation is going to be 32,800 times 0.81 to the x power. Now I can fill in my chart. So if I can do these each individually. I can put in 4 and figure it out, put in 5 and figure it out, or I can use my table if I've got a calculator like this. So I go y equals, clear that equation, 32,800 times 0.81 to the x power. Hit enter. Go to my table. Okay, so in year 4, it tells me this car is worth $14,119. In year 5, it's worth $11,437. In year 6, it's worth $9,263.70. Year 7, $7,503.60. Year 8, $6,077.90. Year 9, $4,923.10. And year 10 is worth $3,987.70. Okay, if you don't have a graphing calculator, you can make a table like this on Desmos. Okay. All right, so you buy a new car for $37,000 and it depreciates at a rate of 11.2% on average each year. How much will the car be worth after 10 years? Okay, so here's what you got to do first. You got to figure out how much of the value it retains each year. So out of 100%, it's losing 11.2% each year. Okay, so that's going to be 0.8. This is going to be 8, and this is going to be 8. So it's keeping 88.8% of its value. So my equation then is going to be y equals 37,000 times 0.888 to the x power, which I guess I just want to know how after 10 years, so I'm just going to plug 10 in here. And I get out my calculator, and I go 37,000 times 0.888 to the 10th power. And Y comes out to be $11,280.58. Again, I'm not really concerned about the cents. You buy a used car for $7,000 and it depreciates at a rate of 6.4% on average each year. How much will the car be worth after 5 years? Okay, so again, I'm not so concerned with how much it depreciates. I need to calculate what it retains its value. So 100 minus 6.4. Okay, so this is, it's going to keep 93.6% of its value at this point. So then Y equals 7,000 times 0.936 to the 5th power. So again, 7,000 times 0.936 to the 5th. That car is going to be worth approximately $5,028.95. Okay, real short lesson. You're going to do pages 12 and 13 of your packet. There's page 12. There's page 13. Nicer pictures in Google Classroom, so go ahead and use those, and I will see you guys next time.